Hello and welcome to another video. In this video we're going to be working on find all possible recipes given supplies. And in this one you have information about indifferent recipes and you're given recipes, ingredients, and supplies. And so this is kind of what you think. So a recipe is made out of ingredients and you have supplies. And you have an infinite number of supplies. And you want to return all the recipes you can create. Return the answer in any order. And recipes can be ingredients or something like that, I think. So this is a little bit weird, but yeah. I'm going to give you a bunch of constraints. So recipes and supplies are unique. So recipes can't be supplies. And then ingredients does not contain duplicates, which is also important. So it's not going to be that complicated, where like if you need to keep track of ingredients, it might be a little bit more complicated. Okay. So, and once you make a recipe, you can use it as an ingredient. So that's why if recipes had multiple ingredients that were the same, then it would be a little bit more complicated because you might be able to make one of a recipe or something, but then you can't make enough. Or maybe it's not the case. I would have to think about it because you have infinite supplies, so maybe it's not the case. I guess if you can make something, you can make more of that. But anyway, so in this first example, so we have bread needs yeast and flour, and we just have yeast and flour, so we can make the bread. In the second one, we have a bread and a sandwich. Bread needs yeast and flour. Sandwich needs bread and meat. So we have yeast and flour for the first one. And then once we make the bread, then we have the bread and meat for the sandwich. So we can do everything. Then for the next one, so we have bread, sandwich, burger. We have the yeast and flour. We have the bread and meat, and sandwich, meat, and bread. So we can make the bread with the yeast and flour. We can make infinite of that, right? And then for the sandwich, we need bread and meat, which we now made the bread, and we have the meat. So now we have the sandwich also. And for the burger, we need, sandwich, meat, and bread. So like I said, we can make more of this, and we can make more of this. So yeah. So if you've done graph problems, you kind of quickly realize it's basically a topological sort. So we need some ingredients, and essentially we can start with the supplies. Those are going to be like the 0 in degrees. And then from the supplies, we're going to be able to build up to the things we have. So kind of like, let's show this in example 3, and then we can code it. So pretty standard topological sort. So just make a couple of these nodes. So you could do some things. One thing to consider is you could take everything here and map it to numbers. So instead of having these like strings, you can map it to numbers if you want to. Personal preference, I didn't. So let's say here, our supplies is yeast. So yeast, then we'll have 3 of these guys. Another one and another one. So we start off with yeast, flour, and meat. These will be our green ones. Okay. So first, what we can do is we can take every ingredient and we can draw a graph from that ingredient, or not a graph, a directed edge from that ingredient to the recipe. And if we traverse all the ingredients, then we can make the recipe. So I guess let's actually do that. So instead of these supplies, let's go with ingredients. So yeah, so ingredients are going to be yeast, flour, bread and meat. Make that bread. And another meat over here. Should just copied it. And what else? Sandwich or something? Yeah, I think just sandwich is the last one. Okay, let's just give it a copy. Okay. So what we can say is anything that's a supply. So let's draw these arrows actually. So yeast and flour go to bread. So here's yeast and flour. Get rid of this guy. We zoom out a bit too. There we go. So yeast and flour are gonna go like this. And we can draw an arrow to bread. Not that one. This one. Okay. And then the next one is gonna be, let's see, so bread and meat go to sandwich. So bread and meat go to sandwich. Cool. So let's draw those. And I believe, why do I have 2 meats? What am I missing? The burger. Okay, burger. Okay, so for the burger, you need, let's see, sandwich, bread, and meat. Okay, so sandwich, meat, and bread will, I think you can do this, and then you can kind of like bring it out. Doesn't really help. Whatever, this is fine. Okay, we'll just go like this. All right, great. So now we can just mark our supplies. So our supplies are yeast, flour, and meat. So these are the ones that we can start at. So these are gonna have like the 0 in degrees. So yeast, flour, and meat are gonna have 0 in degrees. And now these recipes have in degrees based on the number of edges that connect to them. So this bread has 2. Sandwich has, I think, bread and meat, so 2. And burger has 3. And then basically what we can do is we can take everything with 0 and we can just put it in like a queue or a stack or whatever you want. So these guys will be, and maybe we can show this like, so these 3 we'll put in a queue or a stack. And then we can just traverse from here. So anytime we pop one of these, let's say we take this flour, we're going to take everything it connects to, and basically we're saying flour, some things might have a dependency on this flour, right? So we're gonna have the in degrees, and also for all of these nodes that have connections, we're gonna make a graph data structure. So it'll look like flour is connected to bread, yeast. So this would just be like a graph connected to bread. Bread is connected to sandwich and burger. And then meat connected to sandwich and burger, I think. Is that correct? So this is, let's see, 6 edges. So 1, 2, 3, 4, 5, 6, 7. So we're missing 1. Let's see, so bread has 2. Sandwich has 1. Oh, we're missing sandwich. Okay, so sandwich goes to burger. That's the one we're missing. So this is the 2 things we need, right? So this in degrees that we're going to have for every recipe, and the number of in degrees for a recipe is just the ingredients it takes, and this graph of ingredient to the things that it's needed for. Okay, so let's say we pop off this flour off our stack. So we're going to say the flour is now gone. So everything that flour went to, the in degrees of that needs to go down by 1. So flour went to bread. So we're going to say this was 2, but because flour went to it, we can now go down to 1. So then we'll just have a 1 here. But we can't put it in our queue yet, because in order to make something, it needs to have 0 dependencies. So we're kind of done there, and the flour is still there. Okay, so now let's say we pop off the yeast. And we'll say, okay, for everything that the yeast went, we'll decrease that. So now go here. So now this bread is actually available, and we can put it in the queue, and we can also mark that we made this guy. So we made the bread. So now we can pop off whichever one. The order doesn't really matter here. Let's say we pop off the bread. Now, same thing. We take the things that the bread was connected to, which was the sandwich and the burger, and we get rid of that. There's a 1, and this guy. Now there's a 2. So none of these are available yet, but the meat was. So we'll take the meat, and then we can lower these. Now this burger is 1. This is 0. So this is available now as well. And this was connected to the burger. So we'll pop off this, and then we can put the burger into the queue. So we're basically able to traverse it all. So the idea is you can use a queue or a stack, whatever. The order doesn't matter. We're not trying to find like a shortest path or anything. So I'll just use a basic array. And we make a graph of these connections, and we also make in degrees. And then whenever something has an in degree of 0, that's available to put into our data structure. And then we can just check, like, anything that we traverse, is it in recipes? And if it's in recipes, then we'll just add it to the result. So the only little bit confusing stuff here is, like, some things can be in a bunch of different things. Normally, you just have, like, one graph with nodes and edges, so it's a little bit easier to see, but this is kind of the same thing. All right, so let's code that guy. So because we want to keep checking if we're in recipes, we'll just turn it into a set. We'll turn most of these things into a set. Yes, we can turn supplies into a set as well. Might as well. Leave ingredients So the problem with actually turning recipes into a set too early is we do want to check if things are in recipes, but we also want to map recipes to ingredients. So we'll do this later, but in the beginning, let's build our stuff. So we'll have in degrees. Normally we can have an array. We'll just make a dictionary instead, which is fine. And then we'll make a graph. And I don't know if you can have duplicate edges, so just to be safe, we'll make a set of edges. So if we do, we'll get rid of those. All right, so we're gonna go through recipes and ingredients. So we can say like for I recipe, recipes. So for every recipe, let's go through the ingredients. So for ingredient, in ingredients I. So that ingredient is a dependency for the recipe. So we're gonna add that to the graph. So we'll say graph ingredient add I or recipe. And so once we traverse this ingredient, we're going to take everything that it has the weighted edge to, or not the weighted, the directed edge to, and we'll lower the in degrees. All right, and then we can just say the in degrees of the recipe. We don't have to keep adding this up. It's just going to be the ingredients, or the length of ingredients I, right? So how many things do you need before you make the recipe? Just the number of ingredients. Okay. So we have the graph, we have the in degrees. Now we can turn the recipes into a set, turn the supplies into a set. I don't think it matters. Don't care. I tried this with or without a visited set. Seemed to be the same. I wasn't really sure if you can get duplicates. Normally, when things are not in multiple places, like you don't need a visited set. But yeah. So, actually no. I still think you don't need a visited set because when something has an in degree 0, you can never like go to the node that points to it because that dependency goes away. So I think we're good there. I'll have a result. I actually want to have a set here as well. I think. Not sure. Yeah, I'll just do that. And then we'll have like a stack. And the stack is actually just going to start off with all the supplies. So it'll just be supply or item for item in supplies or whatever, something like that. So these are the things that are available right away. Okay. So we could say while the stack has items, we're going to pop off the item. Like I said, doesn't matter BFS, DFS, whatever, or BFS or just normal, doesn't matter. So okay, so we're going to check if the item is in the recipes. In recipes. Does it always have to be? Maybe not. Yeah, maybe it can be in like ingredients or something. Well, no, well actually, yeah, I'm not sure. Like, can you make an ingredient? Can an ingredient? No, because an ingredient can't have multiple things to make it. I don't think we have to do this check, honestly, now that I'm thinking about it. I think we can just go res add item. This is fine. We'll see what happens if we have an edge case. If this was like an interview setting, I'd just be a little bit more cautious and double check. But I think this is unnecessary. Okay, so then we have to go for child in graph item, lower all the in degrees. And if the in degrees of the child happens to be 0, just add it to our stack. I think that's it. Yeah, so in that case, if we don't need to check if it's in recipes, don't need this. I wonder if you need the set. Let's just go super whatever. We'll see what happens. See if we get some errors. Like, yeah, normally I'd be cautious, but whatever. We'll see what happens. And then we just return result here or something. Let's give that a go. Let's see what errors. In misspelled. In degrees. Okay. Oh, this is a pen now. Okay, so we did get the wrong thing. Corn. How do we make corn? Oh, right, because we're just straight adding supplies. Yeah, so that is, I mean, we can check if it's not in supplies, but yeah, I think the better thing to do would just be, yeah, recipes. And then we can just say if, yeah, so I didn't catch that. So because we do have supplies, like we don't want to add supplies in. Let's see if any other shortcuts was bad. And yeah, like I said, if this was an interview setting, I'd just be super safe because I wouldn't be super sure like what we can get rid of 100%. So, okay. Yeah, so pretty good. And yeah, the main thing here is just to recognize topological sort. There's dependencies. Whenever you have a dependency graph where like you need a bunch of things to happen for something else, topological sort's usually the way to go. It's not super complicated. All right. So time for topological sort is usually E plus V. So I guess E here is like ingredients, right? Because for every ingredient, so it's not going to be length of ingredient, it's going to be the actual total items in the ingredients. Because for every ingredient, you have an edge to a recipe. And then V is recipes. So this is going to be like length recipes plus length of this whole big guy. Which makes sense because we're basically traversing edges and getting rid of them. Like that's kind of what the algorithm is. You traverse edges, you get rid of them, you can only do that once. And then you add nodes that those edges connect to. Yeah. Okay. Space. So let's see, graph. Yeah, so this is going to be E plus V, I think. Right, like a graph can have nodes and edges. And then, so it's going to have all the edges and then, yeah, nodes for keys. So I guess like E plus V again. Usually worst case, E is just going to be way bigger than V. Yeah. And then recipes is just length recipes. So like you could say this is V. Yeah, I think it's like E plus V as well for the graph, or just E, I guess. But the keys are nodes, right? So yeah, like worst case, yeah, something like that. Okay. For these kinds of problems, like I think you can be a little bit off on time and space because they're kind of not super simple to come up with. It's not just like a for loop or something. Okay. So yeah, I'm gonna go with this. And yeah, so kind of interesting problem. Want to do this one? Let me know what you think. And yeah, cool. Thanks for watching.